Okay, so we're going to graph our parent function. Our parent function for a rational is just plain 1 over x. Now, our rational functions, the shape of them, are mainly determined by the asymptotes, okay? They're mainly determined by the two asymptotes. Now, this rational function hasn't been moved anywhere at all. So the two asymptotes we have, you can't really see it, I'm so sorry, but I'm drawing a dotted line on the x-axis. Our first asymptote for this parent function is along the x-axis. What equation represents the x-axis? Yes. Oh, no. Y equals 0. Why is it y equals 0 and not x equals 0? No matter what is y equal to along the x-axis? 0. So the equation for the x-axis is y equals 0. The other asymptote is the y-axis. Another dotted line. What equation represents the y-axis? X equals 0. Wonderful, because no matter what, no matter where we are, x is always 0 along the y-axis. Does that make sense?
Yeah.
Okay, so we first, when we're graphing a rational, draw the asymptotes. Then we figure out 2 perfect points for our line. When we're drawing rationals, all we need are 2 perfect points. You got lucky. Right? Before we had to have 3, now we only need 2. We need 1 on each of our 2 curves. So let's do the easiest one. We're going to draw our little x and y table, because whenever we're confused about graphing, we always draw the table. When x is 1, what is y? What is 1 divided by 1? 1. So I'm going to plot the point 1, 1. When x is negative 1, what is y? Also negative 1. These are the only perfect points we need on our graph. So as long as you draw the asymptotes, have these 2 perfect points, you're good to go, and of course draw your lines. Now, I always struggle drawing these lines because we said, how do asymptotes make the graph behave? What happens? Does it ever curve away from the asymptote? No, it keeps on doing what? Getting closer and closer and closer. So I struggle because I accidentally always end up drawing a curve. You got to be careful not to do that. So I'm going to be careful here. Well, I just changed colors. So there's one of my curves. And there's my other curve. Yes? Make sure it has a curve, right? You're right that as it gets more and more compressed, it will look more and more like a 90-degree angle, but it never actually is a 90-degree angle. Yes?
Doesn't it eventually have to touch?
No. That's what's so amazing about it. Think about, okay, so when you're thinking about asymptotes, you're getting closer and closer and closer and closer. It's just like if you're dividing a number in half infinitely. So if I start with, say, 4 and I divide it in half, what do I have? 2. Divided in half, what do I have? 1. Divided in half, what do I have? Divided in half, what do I have? 0.25. Divided in half, what do I have? 0.1. 0.125 you actually have. You see how it just keeps on getting smaller and smaller and smaller? Can you ever divide by 2? Divide a number by 2 and get 0? No. It's just infinitely small. You'll end up with 0.000000000000001. And it looks like it's on 0, but is it actually? No. It's the same concept as infinity, right? Can you ever actually conceptualize infinity? No. It is weird. I love it. I find it so interesting. And that's exactly how, when you get to calculus, that's exactly how limits work. But we're getting way ahead of ourselves. All right. So this is our parent function. We never actually touch the y-axis, and we never actually touch the x-axis. Are there any questions on how this parent function looks? Quick side note, what do you think the domain of this graph would be? There are two separate intervals for our domain, yes. What is the only singular thing on this graph that x cannot be? 0. So our domain for this is x such that x cannot be 0. That is the only restriction. We're done. That's it.
Is it always that?
So good question. Is the domain always everything except 0?
Oh wait, no, because like whenever it's like scooted over or something, then it wouldn't. It'd be like,
Oh my gosh, exactly.
okay.
If it has been moved, which way? Left or right or up or down will affect it? Left or right. This number will change. If it's moved up or down, what will it change? The range, the y's. Now on this problem, on this function, what is the only thing y cannot be?
0.
Guess what? Your asymptotes also determine your domains and ranges. So asymptotes are very important on rational functions. Yes? Ooh, good question. What about interval? What would this look like on interval notation? Anyone want to take a guess? Yes.
See. Oh no, bracket, bracket, 0. No.
What is your lowest value?
Negative infinity.
Okay.
So
Going up to what? When do we stop? When's our first stopping point?
1, 0.
We stopped at 0, but is it equal to 0? No, so what do you put?
Oh, that's what I meant. Oh, I forgot.
What comes next? Who knows? Yes, you, union. This is all coming back to us, hopefully. And then, when do we start back up again?
0.
To infinity. Range will look the exact same way. It's everything except 0. Any questions there? Did I lose anybody? Yes. So, which one's set? Which one is set? The first one. Set squiggly, set squiggly, set squiggly. Set squiggly. Set squiggly. Set squiggly. SS, set squiggly. We got it, right? Set squiggly. Okay. Yes.
Would 0 have the square bracket?
No, because do we ever touch 0? We can never equal 0, so that's why it's a parenthesis. Always. Any other questions? All right. To explore transformations, we are going to do my favorite Desmos of all time. I know you guys don't care for Desmos all the time, but this is the most fun Desmos ever. So I swear, just give it a try, okay? We're going to go over that. Don't worry. Okay, so based on that Desmos, We were dealing with rational functions. Can you explain to me what number would make the graph move left and right? So is it like in front of the x, on top of the x, after the x? Where is the number? Oh, it's where compared to the x? Directly after the x. Makes it move where?
Left or right?
Left and right. Also, the h value also determines the what? You're right, the horizontal translation. The asymptote. Which asymptote? Think about it. So if it's moved left and right, which asymptote moves? The one that is horizontal or vertical? Vertical, yes. So H, we're going to write this note. H determines the vertical asymptote. The one that is what variable equals something? Which one is the horizontal or the vertical asymptote? X equals, yes. And what do you think makes the graph move up and down? Where is the up and down movement in the formula? Is it in front of the x, on top of the x? It is where? After the rational, after the fraction. Good. So K not only makes it move up and down, what specifically is moved? The horizontal, yes. And lastly, the number that was on top of the rational. What did that do to our graph? Stretch or compress it, yes. Now, does a stretch or compress ever determine domain or range? No, it does not. Good. It does not determine domain or range, therefore it doesn't determine our asymptotes. Stretch or compress does not affect the asymptotes. Also, side note, if I had this, what type of stretch or compress do we have here? Is it inside of our parentheses? No. It is a vertical what specifically? It's not a stretch. What does a stretch look like? This is a vertical stretch of 2. This, it's a half. It's the 1 and the 2 combined together creates a compression of a half. This is important to know. This is a compression, a vertical compression. This is a vertical stretch. Good. So here, this is a vertical compression by a half. That's the trickiest part about this. That's as hard as it gets right there.
So what if there was like 3 and 11?
That'd still be a, so you're saying 3 up top and 11 in the bottom? What would that be? Is it less than 1 or bigger than 1?
I'm not good with my fractions.
Is 3 less than 11 or bigger than 11?
Less than 11?
Okay, so 3 divided by 11. Is that bigger than 1 or less than 1? Yes. So it's a,
Compression.
yes, a vertical compression. We got it. We got it. All right. Over here, I want you guys to tell me what transformations are happening on A and B. You tell me what transformations are happening on A and B. If we have a 1 up top and nothing on the bottom, is it stretched or compressed? No, it is not. Good. There's 1 on top. Has it been stretched or compressed? Ooh, shoot, thank you. If the inside parentheses would be out.
It says H is less than 0 is left. Oh, wait, 8.
It means that
This is a negative 8.
it's
So
our
that goes
stretched.
left, not right.
So like if it was a 2, is that bigger than 1 or less than 1?
So I thought it was
So it's a,
right here. So left, H less than 0, right?
which that comprises of the greater 1 and then 2 now. You get it?
It says at the bottom.
Yeah.
I was thinking.
It's tricky.
So you know how
Tricky works. It still works.
Exactly.
to the left?
Yeah.
Well, right here.
Is it to the left or right?
So I don't know if like.
I'm a savvy. That's how
It
positive.
still has the same rule. H is always backward.
So negative 8 is
Like,
right.
That's tricky.
Yeah, that's what I'm thinking. I might have read
Because it
it.
says
Then it would
left
left.
or less than 0.
So right here, it's saying that it should go left. So is it just sunroof? It is or is not? I'm chilling. So this is left. Why is it right? You say it's
Yes, I forgot to
left.
mention that. Yes. All right, thank you for bringing this up. Let's take a look over here. Where the heck did I put my pen? Jeepers. Okay. Well, we're going to pretend. When H is less than 0, which way does it go?
Right.
When H is less than 0, which way does it go?
Wait, she said.
Misprint. When H is less than 0, it goes to the. When H is bigger than 0, meaning it's positive, where does it go? Left. Thank you. For those of you that pointed that out to me. There's my pen. It's always tricky. H will always be tricky, no matter what. Always.
Can we use something else than that? Because it just reminds me of this.
Tricky.
Yeah, I don't know.
I'm sorry. We're sticking with it. It's stuck in my head now. I can't get out.
Yeah, Miss T left a lot of stuff behind.
Okay.
Where my pencil go?
It's in your pocket?
Yeah, right.
We're now going to use what we know about the transformations. We're now going to use what we know about the transformations to determine the asymptotes and domain and range. Which one do you think we need to find first? Asymptotes, because asymptotes determine the domain and range. Wonderful. So, do I even need to quickly sketch this? No. Where is my vertical asymptote? X equals y negative 3. Tricky. And where is the, so that was vertical, where's the horizontal asymptote? Yes. Now, our domain, X is everything except what? This time it's been moved. Our asymptote's been moved, right? So the domain is everything except, our domain is everything except -3. Good. It's no longer 0. It has now been moved to -3. So our domain, can anyone take a guess? I want set notation first.
X is such that.
Yes. X is not equal to what? Wonderful. What about the range? Someone I haven't heard from.
Spencer.
Whoa.
Take a guess, Spencer. Come on.
Wait.
Step it up. You can do it.
Okay, so, alright, you like the Y?
Yes.
Y.
Yes.
Line,
Such that. Good.
yeah, and then Y,
Yes.
is not equal, to -5.
Yes.
I know, I'm so smart.
Exactly. You got it.
Yes, I do.
Does anyone want to volunteer for the interval notation for domain? Even though I've heard from you a bunch, Taryn, it's okay. Go ahead.
Okay. Bracket and then -infinity, comma, -3, close bracket, U, bracket, -3, comma.
Beautiful, except technically these are parentheses. Brackets are those. Okay? These are parentheses. But I knew what you meant. You would have written it right. And does anyone else that I haven't heard from want to volunteer for the interval notation? Yes, Ella. Wonderful. So as long as you know the what? Asymptotes, can you figure out domain and range? Easy peasy. 1, 2, 3, Z. Any questions here? Okay. What I want from you, you are going to find the equation for this graph. Then you are only going to do part C here. And then you are only going to do part A here. 3 problems.